So now let's talk about data input. So what data input basically is the user inputting some sort of data and getting some reply back from from the console or the system by it does like some sort of calculation or manipulation of the input data and returns some sort of output. So this is done with the following two functions. We have both input and raw input functions. Now, the difference between the two, so I have some code right here we're going to work with later. Input itself is it's the current on the current version Python 3. It's used for input and for prompting the user to input some sort of string and getting a reply back of the string. In the older version of Python, like in Python version 2, we have raw input. And in version 3, this doesn't work anymore because they completely removed it. So now we just have input. So before I continue, we're going to have to set up how to allow Sublime Text to have like sort of console input because like as it is, when we build it, it doesn't work as it should. As you can see, it prints out the the prompt string, but it doesn't do anything. So what we're going to do, we're going to first show you how to actually enable console input, data input onto in Python third version. This is Python Sublime 3, Sublime Text 3. So what we're going to do first, we got to install this package control. And what I did, you just go to Google and let me open this. And thanks to our friends at packagecontrol.io, they provide everything for us, and we just download the package control Sublime Text package, and of course you download it, and then you have to find a directory for Sublime Text. So let's find that right now. And in my case, it's 64-bit, so it's in program files. And under Sublime Text 3, there's a packages folder. And here, I already have it placed, but here, as you can see, I'll just drag it in for you. So let's see. Okay, so here we go. We open the containing folder, and it's in downloads, of course. Then we're just gonna drag it into our Sublime Text directory. So whoops, I accidentally skipped. So here we go, we just copy that. And that's pretty much it. And then once you have that installed, you have to restart Sublime Text. So you're going to close that. And then we're going to come back. So let's open up Sublime Text again. Okay, so now we're going to have this thing called Sublime Reply, REPL, under the Tools tab. What this is, it's going to allow us to set up console input for Python. So you go under Sublime RPL, and then we have the Python subtab, and then we're going to have to choose Python run current file. But when we click it, it says file found error. So in order to fix this, we're going to do the following. We have to basically add an environment variable in Windows. So what we're going to do, we're going to have to head over to our system properties. This is done by finding your PC. So this PC in my case, and you go to properties of your system. And then you have advanced system settings. And over here in the advanced system settings, you have environment variables. And then on the lower part where it says system variables, you're going to click on the path variable. And here you have a bunch of various options. And we're going to have to add a new one right now. So we're going to click on new. But before doing that, we're going to have to find the path, the path of Python wherever it's installed. So we're going to find that right now. Just a shortcut way, we're just going to search for Python here. Python, as you can see. And then we're going to go to open file location, and this in my case is a shortcut, so you do the same thing again, open file location, and here it is. And then up here in Windows Explorer, you just click on the search bar, copy this whole address, this path, copy that, you can close it. And then when you add new environment variable, you paste it. Okay, it should be added now. You can close this. And then we're going to restart Sublime Text. So close that. And then we're going to open Sublime Text again. I should really put a shortcut on the desktop. Alright, so now here's our code again. So what we're going to do this time, instead of doing Control B or building it, we're going to go to Sublime Reply, go under Python, and then run. And as you can see, this is a new sort of console, and gives us the prompt. And when I write the answer 20, it echoes our reply. And that's pretty much it. So now you're set up to do console data input in Sublime Text. So remember, don't build. You have to actually go here, Sublime Reply, and go to Python and run current file. And that pretty much concludes this introduction. We hope to see you next time. Now let's talk about file management. To start off, we're going to learn about how to open a file. So first we're going to start off by making a variable called file, and then we're going to equals to the function called open. So before I move on, I'm going to just talk about how the prototype open and what it's supposed to look like. So let's make this a comment. Open, the parameters go in the following way. So we have the file name, then we have the access mode, which can be read or write or both. So access, or let's just say, to keep it simple, actually just say read or write, excuse me. And then we have an optional one, which is buffering. That's basically telling us whether buffering will be used. And we might talk about later, but our focus is file name and access. So let's open our first file. So we have our first parameter, and then in my case I'm using a direct path. If you don't use a path, it'll open this file in wherever your Sublime Text project is located. So in my case, I'm using the path, and if you're using the slashes, don't forget to use escape characters where you have to try it in the slash twice. So we have our file, then we're going to have comma, and then the mode. And we're going to say R for read. Okay, so now we're going to print what we're reading from the file. What we're going to do with this function we're going to have is read. That's basically it reads from the file. So we opened it, and now we're going to read from it. So we're going to print that out, print, and then we have file.read. Don't forget your parentheses. It's a method, so don't forget your parentheses, that's all. Alright, so we're going to build that. As you can see, in my file I wrote hello, so that's it. And then a good practice to have, so when you're done with the file, you close it. Now the method close looks like this, close with parentheses. And then we're going to we do file.close. So basically we use the variable because it's a lot easier. It's basically proper code etiquette. So we have a variable for where we open the file, and then every time we need to work with a file, we have the variable name of where the file is, dot, and the method. So we closed it, and there you go. Alright, moving on. We can read a specific amount of characters in a file. So the parameter in read is as follows. So let's say we have 4. That means that's the number of bytes to be read. So that's approximated to every amount of characters. So let's say we're going to read 4 bytes or 4 characters from the file. So when I do that, hello has 5 letters, and now we're only reading 4 letters. And so that's pretty much it for read. So let's move on to another function called tell. What tell is going to do, it tells us where the current position of the pointer is in the file. So let's say we have our current code, and we're going to print, don't forget, file dot tell, and we're going to print, and what it says, our cursor is at the 4th position right now. So if we change this to 5, it goes to 5. Alright, so we mentioned the pointer. So this is like indicates where we're currently reading from the file. So we have another function called seek. What this does, it allows us to move the pointer within the file to wherever we need to for whatever purpose. So let me just talk about the arguments parameters first. So the first one is the number of bytes for which we want to actually move the pointer, and the other one's optional, so we won't be talking about it too much. So we have seek file.seek, and let's say we want to, so let's take our previous example. So we take this, we have file seek, let's just clean this up a little. Okay, so let's say we're reading 4 characters, and then afterwards we want to go to the end of the file anyway, so for just some purpose. So we're going to do file seek, and then at the end we're going to do file tell, and then we're going to build that. Oh, I forgot to print, of course. So print, and there we go. That should work. Yes. So before, if we take this out, it would have been 4. But now we have 5 because we moved the cursor to the end of the file. And that pretty much illustrates how that works. So what we can also do, we can read, let's get rid of all this. We're not going to need this right now. Alright, what we can also do, we can also read the file one line at a time by using a loop. So for line in, so we can actually use loops with the file itself. So let's say you have a bunch of text. So let me just write this out first, and then we have line. So this is going to read line per line, and of course after we're done, we're going to file close. Alright, so let me just go back to my file, and we're going to add some lines. Line, so let's just copy a bunch of line. Alright, so we have hello and then a bunch, 4 lines. Alright, so let's print this out. Oops, and I forgot something, hold on a sec. File close. Okay, so in file, let me just check my syntax. I forgot the colon again. Alright, so there you go. It used the for loop to print every single line, because if we just did print line, it would just do one line, or just print file would do one line until the end character. So in this case, it printed every single line. And then you just close it, as we usually do in proper practice. And so now what we can also talk about is so when working with files, we should basically know get to know some attributes. So let's do the following. So we have print, so let's say file name. We're going to just get to know some attributes. So file name, and that's going to be plus, we're adding to the string file dot name. Then we have print is closed, and then we're going to do string function, so display the string of file closed, and then we have print, and then we're going to print the mode that we're in. So you might need these might prove to be useful later on in whatever programming jobs you have. So whoops, I made a mistake somewhere. Where is it? Oh no, here we go. Alright, so it printed out basically what we had in here. So we might need this first. This stuff might come in handy, these attributes, for whatever you're doing. So we returned the file name. We returned whether it's closed or not. So we said it returns a bool. So we want to typecast it as a string. So we said, give me the string. Is it true or false? So is it closed? No, because we just opened it. So, and then we asked for the mode, and I made here mode L, here mode R, and that's pretty much it. So that concludes file reading. Next time we'll be dealing with file writing. To conclude this chapter, we're going to talk about writing to a file. So first we need to write the file with appropriate permission. Now we have, so first we're going to start off with starting with file equals, this time instead of, we're going to open this time. However, we're going to use something, we're going to use the mode W plus. This means we can read and write with this file. Opens the file for both reading and writing. We also have something called WB, which opens the file in binary format. But we won't be using that, so we're going to be using W plus, so reading and writing, to demonstrate how this works. Now, when you open a file in write mode, it's going to overwrite the existing file, or if it doesn't exist, it'll create a new file. So let's make a new file called write.txt. And this is stored in wherever the Sublime Text project is located inside that folder. So we're going to open a new file called write.txt, which we're going to use for reading and writing. So let's do the following. So we're going to do write. We have the method called write, and the argument inside that is the parameter inside that is going to be the string that whatever we're going to write to the file. So we have hello file, I am string. So we have that written. So let's say we want to read what we just wrote now. So once we write to a file, the pointer in the file is moved to the very end. So we want to get it back to the beginning, the pointer, back to the beginning. So we're going to use file.seek and then 0 to go back to the very beginning of the file. So we can actually, go back to the beginning. Alright, so then we're going to print file.read, and then afterwards we're going to close as part of good practice. We're going to close. As you can see, it did it. Now if we removed seek, let's do remove seek. As you can see, there's nothing there because we're at the end of the file. So yeah, that's pretty much that. And then what we can also do, let's do fseek, file seek, back to the end, and we can basically write within that. So let's say so once we use seek, we can write at that position. So at the very beginning of the file, we're going to write a new string as a part of the whole text inside the file. So let's do write. And then from that write, we're going to say this. And then we're going to build. And as you can see, it did it from that, it started from that position. So let's use seek again. So it wrote this, and then after writing it, it went to the very end of that position. So let's do this. And it basically overwrote whatever was here. So it wrote the hell and hello with this because we were at the beginning, so it took 4 characters and rewrote them. And that pretty much concludes the chapter dealing with data input and file management. We hope to see you next time. Hello everyone. In this chapter, we're going to talk about data structures in Python. So what data structures basically do is that they help us organize data in our machine so that it can be used more efficiently. But we won't be talking about the actual theory behind data structures. Instead, we'll focus on how to actually use them in practice. So the first one we're going to talk about is called the tuple. What a tuple is basically a sequence of immutable objects, which basically means that once you create a variable of the tuple type, you can't change its elements. So let's define a tuple in the following way. Hold on. Tup equals, so we have one, then a string A, B, C, comma, 2, and then again, and then C, D, E. So here's our tuple. Another way it can be done is like this. So we have tup1 equals, so without the parentheses basically, 3, E, F, G, and then we say true. These are just parts of the tuple. And to define a tuple with the single value, you just do the following. So tup2, for example, equals capital A. Or it's also can be done as, so this also, I'm going to just write in comments, so you could say tup2 equals, in parentheses, A, and then comma. And just keep in mind the comma is essential when you just have one element in the tuple. You can print out the elements, so moving on actually, you can print out the elements of a tuple using the print function. So it'll just print them all out. It's not capital print. Yeah, this keyboard's kind of weird. Tup. Alright, build. So it basically printed everything out with the parentheses and everything. You can also print elements of the tuple. So let's do the following. Instead of saying the whole tuple, we just say the first element. Remember, not the first element, so 0 is inclusive. So we have 0, 1, 2, 3 in this first tuple. So 0, 1, 2, 3. So when we said 1, that means we got A, B, C in that tuple, but when we say 0, we got the 0th element. So you can also use indices to slice the tuple. So 0 colon, that's done by doing the following, 0 colon 2, for example. That means we just want to get a certain portion of the tuple. So you just want 0, the 0th position and the second position. To the second position, or actually, give me I should be say this. Give me 2 elements from the tuple starting from the 0th position and counting up to 2. So 1 for the 0th and 2 for the first. So it's kind of confusing, but just say, okay, starting from here, give me 2 elements starting from the beginning. So 1, 2. Okay. So moving on, we already mentioned that tuples are immutable objects, so we can't change them. But so what we can do, we can assign a value to a single element of the tuple, but we can't change it later. So we'll do the following. So let's erase this. Give me a sec. So we're gonna do a try, and what we're gonna do, and then this, we're gonna try assigning a value to the third element of the tuple. So tup3 in square brackets equals 5. And as you probably already can tell based on what we said before, this isn't going to work. So we're going to do exception as E colon print E, and you're going to see what's going to happen. Tuple is an object that does not support item assignment. So as we said, this backs up our claim that we said elements can't be changed at all, so they're immutable. And that pretty much solves that issue. And now what you can also do, we can do as follows. So let's try another piece of code. So let's erase that. So tup, we're gonna actually use 0. We're gonna splice. whatever, plus 5 comma. So what we're doing here, we're going to let's just type it out. What we're going to do, we're going to add an element to the very end. So what we did, we got the whole, we said, okay, so the tuple now is going to be the following. So the tuple is going to, from after the final element, we added another element 5. And we said, okay, so now we have the 5th element. So this means we can conclude that all operations that are applicable to strings are also applicable to tuples. And therefore, we can multiply, use the multiplication, print, so tup times 8 times tuple 2, oh actually let's say 2 times 4. It's going to print it out 4 times. Another operator we can use is the membership operator. This operator is used for checking if an element belongs to a tuple or not. So we are asking, so let's print out, does 5 belong to tuple? Is there a 5 in tuple? And that means it returns a bool. So yes, it is. It's in there. And it is also possible to use tuples in iteration in loops. So let's do that too. So I'm just writing a lot of code, just adding things on to save some time. So in 4x in, we've got A, B, hold on a sec, and C. So this is a tuple for using a for loop using a tuple. So we're going to say print x. And we're going to do that. And there's a mistake here. So, forgot the colon again. Alright, let's see what the problem is. Name x is not defined. That's because I used the capital X. Whoops. Keep my finger on the shift key. Alright, so it said, okay, now we're going to print the whole tuple in a for loop. So A, B, C. And we find tuples very useful when there are needs to return multiple results from a function. So let's do that as well. So define multiple results. Actually, caps lock result. And then we're going to say, okay, so give me the tuple, return 1, 2, and then A. And then we're going to say print multiple results. So with tuples, you can get multiple results. I forgot there we go, multiple results. And you can compare two tuples with one another. You can compare two tuples with one another by doing the following. So you do print. We're going to do manual tuple 1, 2, 3 equals 1, 2, for example. So you're checking if tuples are equal to each other, which these are not. Syntax error, hold on a sec. I forgot a parentheses. There you go. And as you can see, it's false. So basically, tuples are pretty dynamic. You can work with them in a lot of number of ways, as you can see here. So if you want to look at these again, just pause the video or whatever, and that's pretty much it. Alright, so we have some functions when working with tuples that you might find useful. So we'll just name a couple of them, there will be 3 to be exact. So we have the length function, which returns the length of the tuple. So let's make a tuple. We have tup1. Let's say tup equals, open our parentheses, 1, 2, 3, 4. Okay, that works. So in the length of that, we're going to say of tup. Alright, and then we're going to print this out. Here we go. And you get 3 because you have 1, 2, 3 elements. And we also have another function called max, which gets the max element the greatest element of the function, the max element. So let's see that. Sorry, it gets the max element. And let's just, for safe measure, let's do this. And there you go, it gets the max element no matter where it is. We also have the min function for tuples, which gets the minimum element of the tuple, which is 2 in this case. And we can change it up. Let's make the last element 1. And there you go. So these are just some useful this is a quick tutorial to just tell you a couple of these functions. That's pretty much it. Hello everyone. To sort of piggyback from the previous tutorial, we're going to be talking about the basic data structure in Python, which is a sequence. Now in a sequence, the order of elements is important. And Python has several built-in sequences, and one of them from the last chapter is the tuple. And another type, which we'll be talking about today, well right now actually, is a list. And that is basically, so we're talking about lists. And what's common in all sequences, in lists and tuples, is that every object is a sequence has index elements. So we saw before, we actually used, hold on a sec. We actually used the following. We actually had this tup, and we had index of some sort, if you notice from the previous tutorial. And so that's index element. So each element can be accessed through this index. And these objects can also be sliced, like for example ij, and concatenated with like adding on to it. So tuple equals tup plus some sort of 1, for example. You add 1 to that sequence. And repeated with multiplication, which you'll see again with lists in this tutorial. So for example, repeated 3 times. So a list in Python can be actually written in the following way. So let's say list1 equals square brackets. You do square brackets for lists. 1 ABC 2 3. And if you've noticed, this is actually a tuple, which we'll actually mention in a little bit. So, and list can be printed out in the following way. You just print and you do the name of the list, and that's it, and you print it out. So I just said before, we talked about tuples. You can actually get that tuple because it's the element index in the second index place. So we go index 2 and you get that tuple. Now, since it's a tuple, we might want to access one of the elements inside that tuple. So first we have the index of where the tuple is located in the list, and then we have whichever element in the tuple for the next square brackets, as you can see. So let's say we want the 0th one, and we got 2 this time, which checks out here. And if you want to, now we can also add to this list by, for example, plus, in the element it looks like this. So in square brackets, let's say we want to add 4 as a string, and then we build that. So we added 4 to the end of this list. And we can also multiply the amount of elements in the list. So we can say we want two copies of the entire list. So let's see. Whoops. All right, and we got, see, from at the end, we multiplied the same, we copied it for that many times, for this many times. And we also can use the membership operator like we did in tuples to check whether an element is there. So inside the list, so we say 2 in, for example, 2 in list 1. That basically is 2 located in this list, found in this list. And of course, it's not, as you can see here, remember, tuple is its own element, so it's not equal to 2, just so you know. We'd have to check the tuple itself if you want this too. Anyway, moving on, we can also compare lists, so we can do that in the following way. You just do list to list like we did tuple to tuple. So we did list, and then we have a manually written list, so ABC, and then 2 3 like we did before, and it's true because they're the same, which you can see here. We can also slice lists as we did with tuples, get a certain part of the list. So from the beginning, you don't have to write anything before the colon, then you write 2. So give me the first 2 elements in the list. That's what that means. And if you want to add to the list itself, add an element to the end of the list, that is, you can do the following. So here's our list, and we want to add it to the end, an element to the end. So we have a function called append, or append, whichever way you pronounce it, and the parameter is what you want to add to the end of the list, what is the element on the end of the list. Then we can also do it the following way. So you take the index, not my list, you take the index of the whole length of the list. So give me on the end of the list, and then colon, and there's no end here. So, and then you add the element, and don't forget your square brackets in this case. And then finally, we print it out. So this is 2 ways to do it. This is basically the equivalent of this. Whichever one, it's your choice based on your code. So this pretty much concludes basic manipulation of lists and how we work with them and what they are. Next time we'll be doing three specific functions for lists. So we hope to see you next time. Alright, so there are some special functions when working with lists in Python. So the first one we're going to talk about is the map function. Looks like this, map. So what this does, it takes 2 parameters. One is a function and the other one is a sequence of elements. And the resulting sequence it returns to us is the past sequence to which a past function is applied. So we're going to use lambdas here because it's a lot easier to work with them when we're working with map. So in version 2, map functions would look like this. So we have a map, and in that parentheses we type in our function first as the first parameter, excuse me. So we have a lambda of x, and then we're going to say x squared 2. Oh, let's say 2. Oh, we shouldn't put a space there to be nice, proper. Okay, so x3 times x, and then we're going to have plus 1. So there's our function, and then we're going to have our list. So 1, 2, 3, 4. So if I build this, it's not going to work. It's going to give us this. So in order to make it work in version 3, we have to, on the outside of the map, we have to add list to make sure that we're going to print out a list. So let's add another parentheses right here. Alright, so, and as you can see, it applied every element from this list to this function. So when x equals 1, x equals 2, and so on. Alright, and so another function we have is filter. So let's erase this. So it's called filter. It also takes 2 parameters and a function like before, and the other parameter is a list. And the result is all the elements from the past sequence that satisfy the condition given in the function. So if we say, okay, we're going to have lambda again, so lambda, and this time we're going to have some sort of condition, like, I don't know, like x is less than 4, and then comma to separate our parameters. Then we'll open our sequence, and we're going to have 1, 2, 3, 4, 5, 4, 3, 2, 1. So in version 2 of Python, it's without the list again. So like you would just do this. You would just print out the map, print out the filter, and you get a similar result as last time. So in order to basically solve this problem in version 3, you just add list, this function right here, and there you go. It returned every element that is less than 4. Alright, so the third function we're going to talk about is reduce. It takes the same parameters as before, and the result returns 1 value. So in our example, the function that is passed to reduce multiplies 2 elements. So let's actually write that out. Here we go. Hold on a sec. Alright, so we're going to say print reduce, and then we're going to have lambda x and y. Oops, there should be a lambda x and y. Then we're going to have a colon and then say x times y. And then the other parameter is going to be 1, 2, 3, 4 set. Alright, so now what reduce does is it takes the first two elements of the given sequence and multiplies them. So 1 times 2. The result of that multiplication is now paired with the third element of the given sequence. And the whole procedure is repeated until we get one value as a result. So we're going to see that in a sec. Just this is how you write it in version 2. But in version 3, instead of adding a list like before, you need to import the function functools module. We'll talk about modules in the next chapter. And we need that module in order to use this function. So what we do, we're going to have to just use it for demonstration purposes only. So you do import, and then what is it called? How's it written? Functools. Ftools. And that's how you do that. And don't worry if this confuses you now, this is just for demonstration purposes only. So now that we have this, we can actually use reduce. And what you need to do, when we imported this, we'll just demonstrate this next chapter. You do functools.reduce. Excuse me. And then you just type everything out. And alright. And then there we go. So we got our final result is 24. Now, we could have used other functions as our input as one of these parameters, but lambdas are basically easier to work with, like I said before. So that pretty much concludes this tutorial. We hope to see you next time. So now let's talk about another data type called dictionaries. A data structure, my bad, called dictionaries. Dictionaries are basically collections of key value pairs. So I'll show you what that looks like. So we have key value pairs. And they are known as maps or associative arrays. So each key has a value. And every key is unique. And values don't really necessarily have to be unique. So let's write out our first example of a dictionary. So we're going to call this my dictionary equals, and in this data structure we use curly braces, and then we define our key. So here's our key, and then we have we have key, the key itself, then a semicolon, and then value. And then each pair is separated by a comma. So keys and values can be any type. You can associate them with any data type, anything really. It could be anything you want. And you should define a base depending on your task given to you. So we can have a tuple, for example. You could have a number, you could have whatever. Really anything. And you'll see the results when I print them out. So you have the key and you have the value. And you also have another way of defining a dictionary by using a for loop in the dictionary. So you open your curly braces, and then you write out whatever you need. So let's do this following example. So we have key x, and we have the value x plus 1, and then we have a for loop for x in range 10. And then we're going to print these out. Print my dictionary. There you go. There you go. Alright. And here's an error, a comma again. Alright, so here you go. And keep in mind, sometimes when it prints out the dictionary, it'll be sometimes it'll be in different orders. You'll see in a minute when we add a pair to a dictionary, it'll sometimes be added on the end or added on the beginning. But anyway, so this is basically how you print one out, print dictionaries out. And the indexes, instead of using indexes, we use the actual key. So if we want to get the key from a value with this key, we we open our square brackets with the name of the dictionary, and we type in the key. As you can see, key is associated with value, so we got value. Alright, and if we try to access an element that is not in a dictionary, we'll get a number error. So let's do the following. So we're going to, I think we can erase this, yeah. So we're going to do try, so we're going to do some error handling here, exception handling. So let's do print, and then we're going to do my dictionary, the first one we made, my dictionary with key 1. And then we're going to do except, and then we're going to make our exception as E, and then we're going to print that exception. See what happens. As you can see, we got a 1. And like I said, you just get a number error. Okay, so what we're going to do next is we're just going to basically, there's two functions we have. If you want to separately display keys and values, you have the following functions. So you have keys and you have values. It looks like that. So you're going to take, so we're going to print my dictionary dot keys, and then we get only the keys from the dictionary. And if we want it to do print, we're going to get my dictionary dot values to get only the values, all of them in that dictionary. So we got key, the tuple key, and we got value 5 for values. So, and next, if you want to add an element to a dictionary, we do it in the following way. So let's remove this. We're going to take this away. My keyboard's acting up. Anyway, so what we're going to do, we're going to take my dictionary, open our square brackets, and add a key, a new key. And then we're going to make it set it equal to the value we want to assign. And when we build, as you can see, it's sometimes in random places, but we still got the new key. We got the new key value pair. And if we want to change an existing key value of an existing key, you take the key. So we have 1. Here's our 1, and then we're going to say equal to 3. As you can see here, it changed to 3. Alright, so, and when you want to delete a specified key, you take the following. So we made this, and then we're going to say, okay, let me delete that now. So we do del, it's a keyword, and then we take the dictionary, and we basically open our square brackets and have the desired key we want to delete. As you can see, the one we made here is gone. And so we see that change applied to one object also applies to the other one. And if we don't want this to happen, so we have to create a deep copy of the object. But we will learn how to do this in the following chapters. So don't worry about like anything, if any bigger ideas with changing multiple objects. So anyway, moving on. If you want to remove all elements from a dictionary, it's a new function we have. It's called clear. So you have my dictionary and you have clear. And you print it out and you see it's empty. And that pretty much concludes the basics with dictionaries. Tune in next time. Alright, so now let's talk about something in data structures that can occur when copying a data structure. It's called a shallow copy. So what a shallow copy is, as you can see right here where I wrote, so basically when you have two copies of a data structure, and when you copy them, like simply, they share the same set of elements. So we're going to demonstrate how a shallow copy looks, like what it looks like. So hold on a sec. Alright, so shallow copy, here's our first dictionary. We're going to use dictionaries for this example. So here we go. We have my dictionary. This is a dictionary we made with item, shirt, size, price, and price. Alright, so if we, for example, want to do the following. So we're going to make a new dictionary called my dictionary 1 equals my dictionary. So this is basically just copying it. So since they share the same elements, set of elements, so they share the same elements in memory, they're going to, any changes that occur to this dictionary, occur in this dictionary as well. So first let's print out both of them. Print my dictionary. And then we're going to say print my dictionary 1. Build, and here we go. Now we're gonna do something else in this. We're gonna change an element. So remember we're using the key instead of the actual index, because we're working with dictionaries. So we're going to say the size now equals small in our dictionary instead of medium. So we're going to print that out. As you can see, following the code, this is this is my dictionary, and below is my dictionary 1. So as you can see, medium changed to small in the other one as well, where we usually don't want that to happen if they're two separate dictionaries, which they should be. So we can see, basically we see that one object change an object applies to the other. And if we don't want this to happen, we basically use what is called a deep copy, which we'll be learning about in the next chapter when we talk about modules. So that pretty much concludes this explanation tutorial. We hope to see you next time. So to conclude this chapter, we'll be talking about one last data structure, and that data structure is a set. So sets are objects that contain a collection of unique elements. So like before with dictionaries, you had all repeating kinds of keys and values, but this time we have a collection of unique elements. They are used for removing duplicates from a collection, and are basically used for performing some basic operations from mathematical theory of sets, if you're familiar with them. These include union, intersection, and difference, and we'll see how to type those out in a moment. So let's define our first set. So here we go. So let's see here. So we're going to call it my set, something simple. My set equals, and we have a function called set. We open a parentheses, then we open square brackets inside those parentheses, and we write out our elements. So we have 1, we're going to have 2, 3, and then 1 again. So we're going to have 3, and then we're going to, as you can see, we're going to have a repeating value. So here are our elements in the set. So when we print that set, my set, the duplicates are going to be removed. And so let's talk about those mathematical operations I talked about earlier. So we have union, we have intersection, and then we have a sort of difference. All right, so let's make 2 sets so we can demonstrate these. All right, so we have my set and my set 1. We're going to make set, open parentheses, open square brackets, and then we're going to say 2, 3, 4. Oops, forgot a quote. Here we go. Okay, and as you can just see, union is going to do the following. So let's just refresh our brains a little. So we're going to have my set 1, union, my set. And we got everything without repeating elements put together. So we had 1, so since these are duplicates, we don't display them. So we have 1, 2, 3, 4, because 4 is the new element being added in. Alright, so we have intersection now. We're only going to get the ones that are matching, so we got 1, 4. So we got ones that are so intersection, as you know, takes all the elements that are found in both, that are unique to both sets, and displays them. And the next one, difference, is going to do the following. It's just going to get the one where it's different. That's so in this one we don't have 1, 2, and 3. We don't have 2, we don't have 3, we don't have, and that's pretty much the only unique one. Anyway, moving on. The result of these operators is also a set, and so it can be assigned to a variable. So you just say a equals that. Here, so we do that. There you go. And you have a. And there you go, same thing. Alright, so you can also check if a subset is a subset of another subset by doing the following. So let's say we have a, and that's the variable, and we say less than or equal to my set. And you're going to get a Boolean value, false. But if we did, let's say my set 1, we get true. And we can do it the other way, going the other way, so, which is false because all the value, you can do it the opposite direction. So A has a subset of everything in my set, which is false because my set contains A, the other side A. Alright, moving on. You also have another useful function called, it's the add function, which allows you to add an element to a set. So we're going to do that right now. Let's remove this line right here. And then we're going to say, I don't know, my set dot add. And then inside the parentheses we have our value to be added. So we have 5. Set. Oops. And there you go. So we added it to the set. And that's pretty much concludes this chapter on data structures, and tune in. We hope to see you again, so tune in next time. In this tutorial, we're just going to talk about a couple functions that might actually be useful for you when working with sets. So if you remember last time, in our previous tutorial, we talked about union, intersection, and differences of sets. Now, there are a couple of functions to actually return unions, intersections, and differences without having to write using symbols, which actually we just use functions, which makes it a lot easier for us. So it's simply run like this. So we're gonna have to print it out first. So print, and then we have set dot, for union we just write union, and then parentheses you have our two parameters, which are the sets. First one is the set 1, which set, the parameters are basically just the sets we're using. So we have 2 of them. We're going to print, and you get the union. We also have for intersection, we basically do the same thing, just with intersection. And we also have the final one, which is difference, and you just have, well, the difference of 2 sets. Let's switch these around so you can see a better illustration of it. There you go. So this set minus that set is basically just 4. And that's pretty much it. Hello everyone. So now we're going to move on to modules and packages. So what they do, they serve to break down big programs into smaller logical units. And if you remember from one of our previous tutorials, we talked about decompositions of programs, and this is just that. So we can think of modules as a way of program decomposition on the file level, because we'll have different we'll be importing files, as you'll see later on. So what they enable us to do is they enable us to reuse code in these modules for later. So you don't have to write a function keep repeating writing an existing function and stuff like that. So anyway, let's move on. So to keep things brief, I wrote things ahead of time. So here's our module. It contains functions. It's another Python file contains functions. So, and be sure to have them in the same place as your your other Python file. The module should be in the same file as the same location. So here in my case it's on the desktop, but it could be anywhere, like in a project folder or whatever. Anyway, so since we have that in the same folder, we're going to import. Use the keyword import. As you can see, it's highlighted, which means it's a keyword. So from that, we do import and we do the name of that file. No, you don't have to do .py like .python. You just do import prime. And when we use this, we have access to all the functions in this module, in this file. So primes to, I mean, there's no autofill here, but it still works. And we have a parameter. As you can see, the function worked. And that's this function right here. So moving on, we can also actually import a function with an alias. So what an alias is basically just a different name of a file or whatever, anything really, and we'll name it PR. So it's easier to type out instead of writing prime all the time. You might get lazy, or if the file name is actually really long and you just want to have like a simple letter or whatever. As you can see, it did the same thing. Anyway, moving on, we can also, so let's say we can also just import a function from a module. So if you just need a function, not the whole module itself, you just do the following. So we're going to say from, you start off with from, it's a keyword, module name, import keyword, and then the function you want. We're going to do primes2. And now you just write the function out, primes2. And then you can do the same thing. And there you go. And what you can also do, a use of the function for modules, is the dir function. We'll just call it dir, or dir, this function. What this does, it takes your parameter, the module, as a parameter, and returns all functions that are defined in the module. So we have dir, we have to import, don't forget to import prime, and then we're going to say dir prime. We're going to build. Oh, don't forget you got to print it as well. There you go. And so in the next tutorial, we'll be explaining, because this kind of piggybacks into packages. So we'll talk about these results in the next tutorial. So tune in next time. So now we'll briefly talk about and explain what packages are and how to create them. So to create a package, we copy all the modules that should be in a package into one folder. So basically a package can be treated as a folder, but with a special file, that's a special Python file with the following. So you have this, it looks like this. So 3 underscores, so underscore, init, and then init, and then 2 underscores, and that's the name of the new Python file. So this basically treats a folder as a package. So let's make one of those folders right now. So a package can contain several modules, which are basically files that can be used when you import the whole package instead of importing multiple modules. So let's call this main. And first, we're just going to copy this on over, rename it to that. There you go. Okay, so now this main folder is a package. And you can also have sub-packages too, so folders within folders with this file. So new, you just make a new folder. There you go. Copy, and then, so make sure you have this file, the initializing file, inside each folder, and then you have a sub-package. You just make 2 of them, rename them, and be sure the package, the whole package folder is inside the same directory as your Python file. Alright, so there you go. And you know what, for the sake of the tutorial, we'll also have prime, the module prime from last time, inside one of the sub packages so we can demonstrate how they work. Alright, so there you go. Package is ready. It's called main. So now we import the package. What we do, you do import the main package's name, and for sub packages, for layered sub packages, you do the following. So sub, and the hierarchy is by dot. So main sub2 dot module. So our module is called prime, right? And then you have to use an alias in this case. So as sub2. Alright, so now when we do sub2 dot primes2, the function from our module we used from last time, and there you go. We get the function. We get this function and everything works out, checks out here. And so and you could also do the same with a single function like from before, but this time we're using packages, of course. We have from, then you do the same, the import from main sub2 dot prime, and we just want the function, for example, import the function name, which is primes2, and then you just write primes2, and that's pretty much it. So that's pretty much how packages work, and that concludes the tutorial. So now that we've talked about making our own modules, we're going to talk about built-in modules. So in this example, we'll be dealing with the shallow copy problem, which is used in dictionaries, data structures in general. So what a shallow copy is basically when you copy an object, or like for example a dictionary, the new copy and the original copy will share individual values. So, but what we're going to do now is make a deep copy, which is basically when you copy dictionary, for example, the new copy of the dictionary will have its own set. It'll have everything duplicated. So each one they'll be the same initially, but they'll be duplicated. So let's jump right into it. Okay, so now this built-in module is called copy. So here's what it looks like. So import copy. Alright, so let's make a dictionary. My dictionary equals, and now we're gonna have some if you were from last time, so key value. We have our key value pairs like we said before, separated by the comma, and then we're gonna have our tuple key K E Y. Let's make it capital Y, and then colon 5. Alright, so now we're gonna instead of copying it, it's gonna look like this. So we have copy dot deep copy, and then the parameter is your dictionary data structure, my dictionary. Alright, so this is a built-in module, and it creates a deep copy using the function with this built-in module. Alright, so now to make some difference, we're just going to add my dictionary. We're going to do this code right here just to make a little difference. We're going to add the key pair 1 1. Alright, so let's print them out and you'll see how this built-in module works. So my dictionary, this name is my dictionary 1, my dictionary, and then my dictionary 1. Alright, build. Here we go. Oops, there we go. So, as you can see, it copied everything, duplicated every single thing. But just to make a difference, I added in the first one 1 1 pair. So another module we have is math, the math module. It's built in, so when you import and do math, you'll have a lot of mathematical functions like cosine, exponent, ceiling, and we'll do those right now. So we can delete all this. We don't need dictionaries anymore. So let's print, and then, oh, you could alias this. You don't have to because it's short. So math as m, and then we're going to do m dot cos for cosine, and then you have pi in the module, so that should work. So cosine of pi is -1. And then you have the exponent, let's do this, exp, and then 1, and you get e, so exponent is e to the power of whatever, so e to the power of 2, for example, is that, and so on. And you have ceiling, which if I might have talked about it before, but it gets rounds up, so ceiling of 1.6 is 2. And you also have a complex number module, so it's called CMath, so we can do that too. So import CMath as CM, and what you can do with this, let's find out. Let's do dir, if you remember that from CM. We're going to print that. As you can see, it shows everything, all of the functions, all the modules we have in this package. Anyway, in this we have all the functions we have in this module, excuse me. And then so we can use something like square root. So square root. We're just explaining all of the maybe the useful functions you need. And I forgot the number. Let's say 4, 2, and it shows that as a complex number here. So as you can see, plus 0j. And we could also do polar in the following way. So let's do that. Might be useful for some of you. And we're gonna say, so we have a complex function 2. There you go, 0, 0. And wait, oh, forgot something. Forgot our parameters. 0, 1. And there you go. There's that. And we also have a random module, which is called import. It's called random as r. Let's call it ran. And what you can do, you can generate random numbers with this one. But let's see what dir ran build, and you have all these functions in there. So in this module, you can generate random numbers using different functions. For example, you have sample. Let's see, you have ran.sample, which generates a random sample of 3 elements. So we have the parameter like a list, for example. We have, here we go, 5, and then we have 3. Oops, I made a mistake. Hold on. It's ran sample. I forgot something. Parentheses. And there you go. It took a random. See, it goes randomly. We also have random, which uniformly generates a random number from an interval. So random. I don't think we need this. Here we go. Just get some parentheses in there. Alright, so generates a random number from 0 to 1. So let's say 10. Oops. But yeah, so it generates a random 0. So if you want to do like 10, for example, you do parentheses 10, up to 10. This is up to 1 basically, so from 0 to 1. Let's try 100. So as you can see, it just returns 0 from interval 0 to 1. Now, you have an interval option variation of this, so random. So you do rand int. So it makes a random interval from interval 5 to 100, for example. And this, what this does, gets a random number from that interval. So one more module we have is the sys module, sys. So let's import that. So import sys. I don't think we need to make an alias for that. So now let's do something with this. So what this does, this module gives us information on constants and functions that are related to the Python interpreter. So for example, you can get information on the max depth of recursion. So let's see that. So we have print sys dot get recursion limit. Go, and you have 1000, so you can have recursion up to 1000 times. You also have print sys version, where we can see, hold on, what's this? Oh, right. There we go. And it tells us the version of our Python, what Python interpreter we're using. So mine is 3.51. We also have path, which shows us where all of the modules are. So this module, the sys module, allows us to pass arguments from the console when executing the script, which you can see in the following. Just let me get this file, prime test. You can see how it's used here in a module I made before. So you have it here being used. So it takes one argument from the console, the first argument, when you press enter, and it takes one argument from the console when you run this module in the console. And that's pretty much it for this chapter. We hope to see you next time. Alright, so in this chapter we're going to be talking about something that's sort of advanced in programming. It's called Object-Oriented Programming, or OOP for short. So in this tutorial we're just going to basically talk about the basic concepts and principles of OOP and what it is used, how it's used and why. And so we'll just basically talk about the whole idea behind OOP. So the whole idea behind it is basically to create a class that contains descriptions, definitions, and all possible actions that can be performed on data. So these defined actions are basically called methods or functions. I'll be using methods more often than functions because in OOP we like to use methods more. And so keep in mind that once you write a class and define all of its methods, you can only use defined methods when working with data. So you can't have basically anything random, and everything's predefined. So when talking about OOP, it is important to mention these four basic principles. So we have the following. We have hiding. So we're going to have hiding information. We're going to have encapsulation. And then we're also going to have inheritance. And last but not least, polymorphism. So what hiding info is, so basically what this means is that a user does not need to know how the class is implemented. They just need to know what the class can do, and so or what that is basically is what methods are defined in the class and what its purpose is. So there is no need to show implementation of class instances. And it's good to note that an instance of a class is a variable that is of the class's type. And so we have encapsulation, which basically means that all variables, basically instances, and methods are logically grouped together. So you won't have anything random. You'll see later on that we'll basically make it with cars, for example, vehicle. A car is a vehicle, a truck is a vehicle, and so on. And then we'll also talk about inheritance and polymorphisms at a later time because they're more kind of complicated. So it's basically impossible to explain all these things at once. So we'll learn about these things in examples. So this will be an example-focused tutorial kind of chapter. So keep in mind that some of you will find this topic kind of difficult, but that's okay because it's recommended for everyone, all programmers, to explore this topic in detail, and also the discussion section is there for you if you have any questions. So that's basically it for this introduction. So just tune in next time and we'll be on our way with object-oriented programming.